350 mm in the bearing surface. The left part is the body. This is the body. The fourth one is the cup. Bar. Matching the profile part. Now here center line. The height is 185 mm. Next, draw the profile. Later you can constraint. So give the dimension. Smart dimension from here to here. The distance is 50 mm. And from here, I will dimension. Normally it is 0 h. 7 standard is this 20. Okay. Now, if you observe.
नहीं पर मुझे लगता है कभी कभार इसलिए भूल गया था बात में से भूल गया इस बात में लड़ाई नहीं होती कहीं ऐसे भूल जाता है नहीं कर नहीं सकता मैं तो पर जिसको दिया उसे तो याद भी कर
These two 12 mm. Next comes the distance sketch. So, place it. Just click OK. 275. 275.
This is the from here we are going to start the assemble. Observe carefully how
it's completely constrained. Let me put an arc here. Okay. Let me draw this arc. We go to arc. Okay, you can go to portion of the arc. Exactly here. Click OK. Control 1. Control 7 isometric. So this is the Tommy bar. At the end, you can apply a small chamfer. So go to chamfer, apply 1 mm chamfer around this edge. Click OK. Let me save this file, Tommy bar. So this completes the part modeling. Now let us move on to the assembly. Close this, go to new, assembly. First part is body, open. Click on the screen, body is fixed. Now let us go to the second component. That is the nut, insert component. So here we have nut, click OK, open. Now apply the mates. So select this, go to mate. Select this cylindrical, click OK. Now drag this up, select this face, click OK. So still this object can rotate. That is why you can see minus symbol here, which indicates that it can rotate, not an issue. Control 1, Control 7. So nut is done. Now let me go to screw spindle. Screw spindle, insert it. Now mate, select this, click OK. Don't mate this to this. Why? Because they have given the distance as 350 mm. We need to take into account. So that's why. So whereas it can rotate. So if you observe here, this can rotate. So this rotation motion can be given constraint. Why? Because when you go to the drafting, when you draft it, at that time the Tommy bar should be exactly towards right side and it should be perpendicular to the right profile plane. So in order to do that, we need to make this hole perpendicular to the right profile plane. So in order to do that, what I will do is I'll switch on this temporary axis and I'll select this and select the right plane. Go to mate. So default it will say parallel. I want to make it perpendicular. Click OK. Right? It cannot rotate now. It can move up and down. Why this is important? Because when you go to the top view, when you do the half section at that time, if it is inclined, then section view will not be proper. So only for drafting purpose, we need to constrain this. Practically speaking, this will not be constrained because it has to be rotated. Control 7. This has been constrained, can move up and down. Now let me assemble the next component. So 3 components are over. Let me insert the 4th component. So 4th component we insert as cup. As usual, what we should do, we should select this, mate. Okay, click OK. Similarly, I will push this up, select the surface, click OK. Now I have to constrain this also. It can rotate. Okay. How do I constrain this? Select this, apply parallel. Now it cannot rotate. It cannot move up and down. So it will move along with the spindle, not individually. Click OK. So this is done with screw spindle. Next is the washer. I'll go to insert component. I'll go to washer, open, place it. So similar to all of that, so you can switch off this temporary axis. Go to mate. So select cylindrical surfaces. Right? So many times it will happen. The component will go in and will not be able to see where the component is. At that time, you can always hide the component. Okay? And you'll be able to see the components. For example, now you can see the washer. Now you can always show the components. Right? So in assembly, you can make use of the show components or transparency, and you can see where the component is. Right? So this is, let me apply the face mate. Select the screw spindle top surface. Select this bottom surface. So mate, sorry, I didn't select the mate. Select the mate and apply. Okay. Click OK. To visualize this properly, you can go to wireframe model and you can check. Right, so screw spindle will move above this because you can see the distance. There are 13 mm and 12 mm. 12 mm is in the cup and 13 mm in the screw spindle. So it should sit on top of the screw spindle and properly align. Okay. Wireframe, make it a solid model, Control 7. Now I should insert the CSK screw. So go to insert component, CSK screw, countersunk screw, place it. Now mate this with this, click OK, pull this up, surface is being pulled. This surface with respect to this surface, select the surface, this surface, click OK. Right, now this is not aligned properly because it can rotate. So what I will do is, I will select this face and right plane, select this face and select the right plane. Make it parallel or perpendicular. Right now it has applied parallel. So click OK. Control 1, Control 5. You can see exactly. It can be horizontal also, it can be vertical also. If you want to make it horizontal, you should make it perpendicular. You can go to mates here. You can see the mates which have been applied just recently. You can go to this mates also and you can see it has applied parallel. Right, so you can always go to this mates and you can edit this mate. Edit feature, make it perpendicular. See, it will rotate and it will make it horizontal. Both of them are correct. So it can be horizontal also, it can be vertical also. Control 7, Control 1. Now in the question they are given the top surface of the bearing, that is the cup, and the bearing surface should be at a distance of 350. That we will do it now. So go to mate, select this top surface of the cup and select this bottom bearing surface. It will move down. Don't worry. Let me click on this distance. So as soon as you click on the distance, you can see now it is maintaining a distance. So the distance they are given in the problem is 350 mm. So by giving this distance, I can fix the spindle distance. Now even once I click OK, it cannot move up or down. It is completely constrained. Clear? Now let me insert the last component, that is Tommy bar. Go to insert component, Tommy bar, click OK, insert it here. Go to mate, the cylindrical surface, click OK. You can select this, you can select this edge. Okay, click OK. Control 7. Right, so Let me save this assembly. Drop it on to, so you can drag this. And they have said top.
Step into the future. Choose from the latest collection of
the screw jack.
In this
Next we'll go for
tutorial,
the
we will learn
exploded
how
view
to
in the
create
SolidWorks
drawing
and
for
bill of
exploded
material.
view, add bill of material and balloons. At first, we will quickly create exploded view. For creation, click on exploded view, select the component you want to explode, click on the direction and drag the component. If you want to view the complete tutorial on how to create exploded view, you can view my previous video. In that video, I have explained everything about exploded view along with animation. It also contains how to create exploded line sketch. For the previous tutorial, link is given in the description. Okay, click on isometric view. The exploded view is ready. Click on OK. Then to create the drawing, click on File. Then click on Make Drawing from Assembly. Then select the sheet format. OK. Then from here, click and drag the isometric exploded and put here. And from here, you can control the exploded and unexploded state by clicking on this option. Then from here you can make it shaded with edges or without edges, or you can keep it hidden. From here you can define the custom scale. Suppose I want to define the user defined 8. Okay, then you can drag and place the view. Then click outside. Then to create the bill of material, click on annotation, click on tables and select bill of materials. Then click on the view for which you want to create the bill of material. Then from here you can choose the template. At first we will use this standard template, BOM standard, open. Then from here you can define BOM type. The first top level type will show only the top level components and sub-assemblies. The parts only will show all the parts, and indented will show the assemblies and part in indented list. We will choose here top level only. If you want to add the missing item also in the bill of material, you can tick this option. From here you can define the start number for the assembly and increment. And from here you can define the table properties. What is the thickness of the table lines? Then click on OK. Then give the point where you want to place the table. Now here BOM table is added. In the column of part number, it has automatically taken the name of the files. If you are using the part number, then you can name your files with those part numbers. Now in this case, I am not using any part numbers. Therefore, I will just double click this part number and make it description. And I will right click and delete this column. I don't need this description now, column. That's all. I need only item number, description and quantity. And if you want to show the material also for the component, then you will have to use other format. We'll just remove this and again click on tables, bill of material, select the view, then browse here and select the BOM with material, then open, then OK, then give the placement. Now here it will show the material automatically. Now for other parts material is not shown. We will see how to place material for one part. The part you want to update, right click on it, click on that, open and file name. Then from here material, right click, choose the material. I want brass. Then click on file, then properties. Then in the custom properties, select here material. Then from here choose material. So it will automatically show that material. Then suppose I also want to show the weight of the component. Click here and select weight. Then click here and select mass. And one more column is there, that is description. If you want to show any description in that column, Then from here choose the description, write down desired description. If you are using part numbers, then you can write here the name of the part as a description. Suppose you support, and OK. Then close the part and save it. Yes, save changes. Here you will have the description. In this column you can have your part numbers. Here you will have description. Here is the material. If you want to show the weight of the component also, then you will have to use other template. Click on tables, select the view, browse. Here is the template for weight. If you take this weight template, it will only show the weight, but I want all the properties of the components. Therefore I will choose this BOM all, open, OK. Then give the position where you want to place. The columns not required by you, you can right click on it and delete the columns. Suppose I don't want this stock size also, and then drag and place. Then shift this view a bit there. OK. And if you want to change the size of the column, you can drag the vertical line. You take your cursor to the vertical line, press hold the first mouse button and drag the mouse. In this way you can resize the table. The next is to place the BOM balloons. Click on this auto balloon. Then from here you can choose the pattern type. If you want it on the top or bottom, so you can give the direction where you want, square or circular. Suppose I want it on the left side. Then from here you can drag it, click any one balloon and drag and place inside the sheet. Then from here you can have different options. If you want order to be sequentially, click here, so it will order it sequentially from 1 to largest number. And if you want to follow the assembly order, you can click here, it will follow the sequence of the assembly. Then from here you can choose the type of the balloon, which type of balloon you want, square, triangular. I want it circular only. Then from here you can choose the size of the balloon, for how many characters it should be suitable. Suppose I will choose these 2 characters, and in the balloon text what you want to place, that you can choose from here. I want item number, then click on OK. Then to place it properly, make a window and select all the balloons, then select one balloon and drag the mouse, click outside. Then you can place it properly. If you want to change the layout, you can drag the balloon
there, but you need
and
to
place it
focus on
wherever.
the part which you want. Alright, one more video.
Quarter planning. Adams is quarterbacking this.
Create a 2D drawing in SolidWorks with the help of a 3D model. Here we created this simple model, and we will see how to make this simple 2D drawing in SolidWorks, and we will see how to make this section views and few basic things we are going to know in this tutorial. So let's start to create this simple tutorial for SolidWorks drawing. Now here we will learn how to create a simple drawing in SolidWorks with the help of 3D model. So this is the simple model we created and we saved as model number 67. Now let's create. There are many ways to create a drawing. So the basic way, just you can ask you your landscape, your size of sheets, so anything you can choose it, but this is the letter we will see. Cancel it. And the another way, you can directly enter from here, make drawing from part assembly. Now see here, any landscape or size you have to choose. So I'll choose here landscape B. Okay. Options, you have to choose any one and drag it. Drag top side. Here click OK. Now even though if you like to increase your, this is your basic or first view, custom scale. Even though you can change the scale from here, see, but that is okay. Even though you can choose from here user defined 3, it's going too small, so 1.5, that's fine, but 2, that's fine. Okay, now even though if you like to change, right click on sheet and here go to properties, and from properties you can change the sheet name. Scale also you can change here 1/2, and angle, third angle is the standard angle people going to choose, so I'll keep third angle. Even if you can change, you will see first angle. Now see, it's changed, but we will keep third angle. This is the standard way. Now even you can choose individual color. So if we want to change this color, here uncheck use parent, because this is your parent. Styles, now see individual I can change, keep high quality. Oh, that's it. You can drag it. Now this one, hidden line visible. Now you will see here hidden lines are visible. Even though we can define the import annotations and dimensions from here also, or there are one more options I'll tell you. Or simply just go to annotation, model item, and here choose entire model. But we will do one more thing, then we will apply a drawing in a full view. First we will see how to make. Now here one option, detailed view, circle, just drag. Now see, click. Now here you can define all the things. Even you can choose hatch, full outline. Even though you can choose uncheck this parent, and see this color also we can change. It's up to us. Okay, now model view, model item. Here you can choose entire model and click all the things so that all the details will come here. Click OK. Now see, all the details comes here. Now let me do one thing, just arranged it, because it seems too hustle and bustle. Now see, even though you can apply, if you want to apply dimension individually, we have option here in annotation, smart dimension, and you can assign a separate dimensions or individual dimensions from here. See, if you click, you will see a small window. You can click here, type a typical dimensions. Now see, okay. Even though if you want to make the dimensions, go to other, use font, uncheck font, and from here we can change the size and font style, everything from here. So I'll keep bold. Size, I feel that's better, or if you like you can make 4 minutes, but bold is enough. Now look, now this is the section view what we created. Those things you don't like, just simply delete it. So this is the section 1. Here you will see a detailed view of this circular part. I told you, even though you can change this one. Okay, this is your drawing. Even we have one more option here, section view. If you go to section view, you will have multiple number of cutting. First we will see, if you drag you will see, so you have to put your cursor on the center and it will ask you section view. Click OK and you will see, drag in any side wherever you like. So let me drag this side. Now here you have too many things. Documents font, that means the same font we will keep. Slice, see, if you click slice section, the only it will show you shaded portion. Okay, now even you can import dimensions from here. See, it's dimensioned. If you uncheck, even though if you like to change color, see, it's changed. That's it. Even though, okay, even though we can change the dimension also from here. So see, this thickness 12 millimeters. So double click on this and here we will change dimension. Let me change 5 millimeter. Okay, now here click refresh. Now see, it's changed. Go to window and click here model. Now see, it is changed. So this is the simple way. Even you can modify our 3D model also from here. Window, model 2, double click and edit. 12 millimeter. Okay, refresh. That's it. So this is these few basic things which is really helpful for creating a drawing in SolidWorks with the help of any kind of Back to CAD/CAM tutorial. Today we are going to learn how to create a 2D drawing with the help of 3D model. In last lecture we created. We will learn some basic tools. Either you will find one option here, exit and go to click drawing. It will okay, mold view. Even though there is one more option, standard 3 view. If you choose this one also, you will get directly going to use T3 placed here. Select this. It's this. In this 2 is to 1. There is 10 rest to 1. Let me save this. Okay, I can drop left, create and go. Now for your drawing to dimensions, here the auxiliary click section. So to click on this view. Even though you can change the default, so we will keep as it is. And dimensions we will allocate, so no need to define from here. And okay, this hidden line removed so that we will get a perfect inside shape here. If you direct double click on this edge section, so here from here you can change 0.5. Even though you can,
if you are already working as a video editor in India, you can earn 5.
See the gap reduced. Now this is the one way how we simply created. Now let's see one more option here, detailed view. Detailed view added a manual profile. Select this one, font I'll make bigger. Here we selected item. Not everything will be wipe out or hidden. So this is the simple drawing. If you like to edit this one, let's right click, edit sheet metal. Now see, we are in edit mode. If you comes in edit mode, everything will be wipe out or hidden. double click and you will get an option to write something here. So we will write now. See, we are in one. Let's most of the time we use quantity. So this is edit sheet metal. Now see, we are in edit mode. If you comes in edit mode, everything will be wipe out or hidden. Double click and you will get an option to write something here. So we will write exercise 83. Close, click somewhere and you will get, and many things you can write. It's up to you. Even though right click for exit of the edit sketch, simply edit sketch, or simply select here one arrow. You will see this arrow, exit, and once you click exit you will see this drawing. So this is the simple tutorial. If you want to save this, and it will save in your desktop, don't forget to share and like our video, and please subscribe our channel for more videos and more projects in SolidWorks. Thanks for watching.
Alright, I will share you all the links. 1 second.
The cosmetic thread which you have applied, which is of M36, but we have to represent, since it is annotation purpose, we have to represent this as square thread of 38 into 7. So I'll be creating one more video on which a realistic.
In this tutorial, we will learn how to create indented and make it description. And I will right click and delete this.
Open part, go to new part. Now parallel key. This is very quite easy. You can select any plane for that matter. Select and.
Welcome back to CAD/CAM tutorial. Today we will see how to create a 2D drawing in SolidWorks with the help of it. Welcome back to CAD/CAM tutorial. Today we are going to learn how to create a 2D drawing with the help of 3D model. In last lecture we created this one. So let's start to see how to make this beautiful 2D drawing. This is the exercise number 83 we created in our last lecture. Now today we will try to create a 2D drawing with the help of this. So here we will learn some basic tools in 2D drawings, how to create a 2D drawing. So here we have two options. Either you can drop down the file menu, click drawing from part, or even though you will find one option here, create drawing from parts, or simply just click exit and go to file, select new, and here choose drawing. Now once you click drawing, it will ask you which size of sheet do you like. So this is the standard size. If you uncheck, you will get multiple number of size. So I'll always show a standard format, ISO A3 size. This is standard size. Okay, now once you select OK, see it will ask you mold view. You can simply click browse and drag your part. Even though there is one more option, standard 3 view. If you choose this one also, you will get directly placed 3 view. So the basic thing, we are going to use model view, browse. Let me choose exercise 83. Now here it is.
Another. Right here we need to select the drawing sheet size. Right, A3 landscape. Click on OK. Browse item. We'll select this one directly. Right here, give the palette. Now we will go for the drag the views. Open. And after that, go to 50 screen. Go to the file. Make drawing from assembly. A3 landscape. Okay. Now go for here isometric view. Drag it and place it here. Alright, after placing it will ask for the. Alright, if you want to even click the change, you can click for the properties. High quality. Inside things. Alright, okay. Alright, now just click here, add sheet, edit sheet format. Now we can write here. Oldham coupling. Right, click on OK. We can do many changes. Just zoom it. Right, whatever the things that we can have, we can write here. We can make it to the center or to the left side, to the right side. Here. Okay. Now go to the back. Now go to 50 screen. Right, now we will see the exploded view, broken selection, break view, crop view, removed view, annotations, model, projected view, auxiliary view, remote detail. We will go for the detailed view. Here we will select the palette. Now I will go for the left view. Alright. Alright, click on OK now. Select the object, go for the auto dimensioning also is there. Remove section use. Right, if you want, we can see that with hatching we can see that flip direction. Okay, can select this object. Project the view. Remote section, we will go for the detailed view. Detail view, select this round circle. Alright, like this we can go for the detailed view. Next you can make the dimensioning. Dimensioning went so far. Okay, we'll go to Control Z. Adjust below view, adjust to right side view. One second, I will remove this one. Right. Smart dimensioning. Go for auto dimensioning. Click on it. Right, you can see the dimensions. Section view completed, auxiliary completed, projections completed. Alternate position, break empty, replace.